Good morning, everyone. My name's Kira Proctor and I'm the Managing Director of the A Proctor Group Limited, and welcome to today's webinar. Our series of webinars have been running now since 2020, and if you've missed any, you can go back and review them all on demand right here on our YouTube channel. Today we're taking a look at the refurbishment and upgrading of existing buildings, and some of the common problems that can arise. We have a range of RIBA CPD content available for booking either in person or online, and you can find out more information on those at www.proctorgroup.com. Meeting the increased demand for housing has been a challenge for some time, and this has only been exacerbated by the changes in priorities and circumstances brought about by the pandemic and increased home working. Combining this demand for housing with increased emphasis on sustainability makes the recycling of existing buildings an effective and attractive solution. Alongside these practical benefits, upgrading existing structures can play an important role in preserving the aesthetic character and individuality of towns and cities. We'll begin by looking at some of these factors in more detail and consider the aims and outcomes of refurbishment projects alongside the type and scope of refurbishments. We'll also look at the methods, frameworks and guidance used to assess technical performance of the existing structure and subsequently quantify the effectiveness of upgrade works. We'll then discuss the concept of the inherent technical risks associated with particular systems and works before finishing up with a look over some common scenarios and the fabric-first solutions that can be applied. Building refurbishment is a very wide-ranging topic which encompasses a great many different types of structures and systems. We can consider most projects will fall into one of three principal categories: conservation and preservation, upgrades and improvements, and repurposing or change of use. Each of the three types of projects will require a different balancing of priorities and will necessitate a different set of trade-offs to meet the overall goal. Having a clearly identified and realistic outcome in mind before beginning works is therefore a very important part of the design process. Conservation and preservation projects, especially those on listed or historic structures, have a number of limitations that may not be present in other types of refurbishments. Even if retaining the actual period material is not required, the preservation of the essential character and any decorative features certainly is. This requirement can place limits on the extent to which energy performance can be increased, or may restrict the approaches that can be taken to reduce air leakage or control condensation. Balancing the intelligent use of materials with a realistic expectation of what can be achieved, and agreeing a suitable approach with any regulatory bodies is an important prerequisite. Establishing constructive dialogue between designers, contractors and regulators early in the project cycle helps ensure costs and schedules are kept under control whilst delivering quality results. Projects where the main focus is upgrade and improvement work flip these requirements so the primary concern is meeting a performance-based objective. That's not to say preserving feature becomes unimportant, just that the balance shifts more in favour of enhancement than conservation. Although the layout of the building may still impose limits on what may be achieved, particularly in areas such as window and door openings, there's usually a lot more freedom to accommodate fabric insulation, service runs and other modern requirements. Some thought must still be given to achieving this in the most cost-effective manner, as even without conservation considerations, making substantial improvements to the fabric performance can incur significant costs, if not carefully managed. The last category is changing the actual purpose of the building itself, which can range from subdividing a large dwelling into flats to conversions of formal industrial sites. Depending on the purposes of the building before and after conservation, each project will have its own unique challenges, with acoustic performance being a particular concern when converting from non-domestic to domestic use, as many non-domestic buildings, even relatively modern ones, were never designed to incorporate significant acoustic insulation. In this case, as with thermal insulation, airtightness and controlling moisture, the critical first step in any project is assessing the performance of the existing building. This achieves two important aims. Firstly, identifying and prioritising required works such as repairs, and secondly, establishing a baseline relative to which subsequent improvements can be judged. While converting a bedroom to a home office or other basic DIY level projects have a pretty clear functional or aesthetic objective, larger scale refurbishment projects require a more structured and objective approach. We'll discuss these approaches later on, but let's begin by reviewing the basics of building physics and how that applies to existing building fabric. The movements and interactions of heat, air and moisture are what influences most of the decisions we make when upgrading building fabric, so it's important to have at least a basic understanding of the mechanisms involved. Firstly, we'll take a look at heat transfer. There are three main mechanisms by which this takes place: conduction, convection and radiation. Conduction takes place when two objects are in direct physical contact and the heat energy transfers from one to the other. This process will continue either until the contact is broken or the two objects reach the same temperature. Convection is when heat is transferred by a fluid medium, such as air or water. This happens because where the fluid is next to the warmer surface, it heats up. The warmer fluid is less dense than surrounding cooler fluid, and so rises up and is replaced with cooler fluid, and the process starts all over. This sets up a circular current, moving heat between the two objects, which will occur until this movement is restricted, the fluid is removed, or the temperatures equalize. Radiation is the final mechanism, and in this case, heat is transferred directly by means of infrared radiation. The first object emits the radiation and the second absorbs it. The rate at which the energy is transferred is determined by the emissivity of the respective materials. In building context, these properties interact in various ways, but for a simple example, let's look at a timber frame wall with insulation placed in between stud-work. This insulation, let's assume it's a mineral fibre, has a thermal conductivity of 0.035 watts per metre Kelvin. This property is a constant, irrespective of the thickness of the insulation. This is also known as a K value or lambda value and is a measure of how well heat flows across the insulation. If we have 150 millimetres of this insulation, we can divide this thickness by the thermal conductivity to give us a thermal resistance, or R value, of 4.3 metres squared Kelvin per watt. This does vary with thickness and is linear. So if we have the thickness, we have the R value. The higher the R value, the better the material resists heat transfer by conduction. The amount of heat flowing through the entire wall assembly is quantified using the thermal transmittance, or U value, which we calculate by adding all the R values together, then dividing one by the result. The U value is measured in watts per metre squared Kelvin, and a lower result is better. Old, solid or stone walls will have a U value of 2 or higher, while a modern new build timber frame wall will be below 0.2. So this really is an area where substantial improvements can be made in older properties, albeit not always easily. The simple U value doesn't tell the whole story, however, as not all the layers in our example wall are continuous. The insulation in a timber frame wall is typically between studwork, which has a higher thermal conductivity and therefore will allow more heat flow. There are also windows, doors, corner junctions and floor zones to consider, all of which will affect the local heat flows. This phenomenon is called cold bridging, and we account for this by adjusting the U value of our wall to account for additional timber, and then applying a correction called a psi value to account for the corners and floor junctions. By adding continuous layers of insulation or insulating around structural timbers of steelwork, we can reduce these corrections and improve the overall heat loss. Conductive heat flow is not a linear property, however, so the more we want to reduce it, the harder it gets to make further improvements. At modern levels of insulation, it's therefore not always practical to accommodate through extra insulation to make a meaningful difference. So we must look at reducing other heat transfer mechanisms if we want to improve further. The other main area where we can improve our energy performance is by reducing heat losses through convection. This means ensuring unplanned air movement in the building is minimised. Gaps, cracks and poorly sealed penetrations in the building fabric can all allow a substantial degree of air movement, which not only means cold air entering the building in the form of drafts, but also warm air leaking out. Residents of old houses will be all too familiar with drafts, and how much difference basic steps like using a draft excluder or taping closed old sash and case windows over the winter months can make, and when applied to an entire building it can add up to a dramatic improvement. The main benefit to reducing air leakage is that it doesn't necessarily add any thickness to the wall or roof, meaning in older properties space can be maintained and period features can be preserved. There are a few ways to improve the airtightness of older properties, which we'll consider later on, but it's important to consider the effect it can have on moisture in the building. All activities that take place in buildings introduce moisture into the internal environment, and while a drafty older building might have been a bit chilly to live in, this air movement allowed an easy route for moisture to escape. If this moisture cannot escape properly, it can lead to condensation problems, where warm, moist air contacts colder surfaces. Alongside this, traditional building materials like lime mortars and lath and plaster walls have very different hygrothermal properties to their modern equivalents. This means the way they store and transfer both liquid water and water vapour can vary a lot, not least because older materials tend to have highly inconsistent properties. If we seal up all the drafts and upgrade the insulation without a proper understanding of this existing fabric, we can introduce problems with condensation or damp ingress that cause damage to these materials, often in ways that are hard to detect and remedy. For example, let's consider an existing sandstone wall with lime-based plaster, mortar and render. This type of wall has a high degree of moisture permeability and has likely reached a degree of hygrothermal equilibrium and maintained this for many years. If we then add a rigid foam internal insulation system with a low vapour permeability to this wall, that will make the stonework colder, increasing the risk of condensation between the stone and the new insulation. The reduced moisture permeability also limits the capacity for moisture in the stonework to dry out inwards. A more permeable insulation can offset this by allowing more drying, but will allow more vapour ingress, making this a more complex problem than it may first appear. When we upgrade our buildings, we need to carefully balance the benefits modern materials can bring against the risk of upsetting the balance of heat and moisture interactions in the existing fabric. So, how do we avoid these types of issues? The first step is to assess the existing fabric thoroughly, and there are a number of tools and frameworks available to undertake this. The best practice guidance for undertaking energy-efficient focused refurbishment projects is outlined in the PAS 2035 and 2030 documents issued by BSA. The PAS, or Publicly Available Specification, details the steps, assessments and risks associated with each stage of the process, from assessment and design through to completion and handover. While the PAS 2035 approach is aimed more towards commercial or larger scale projects such as local authority upgrade schemes, the steps and recommendations are applicable to every refurbishment project. The document itself also provides a useful framework to highlight the factors that should be considered to deliver any project successfully. It specifies requirements in the following areas: assessment of dwellings for retrofit, identification and evaluation of improvement options, design and specification of energy efficient measures, and the monitoring and evaluation of retrofit projects. The ultimate aim of the standard is to ensure projects deliver a healthy and more fit-for-purpose environment for the occupants, whilst respecting any preservation considerations. The principal factors recommended for assessment are U values of the various elements such as walls, roofs, floors, doors and windows, etc. Psi values of junctions and other non-repeating thermal bridges, condensation risks throughout the structure and the balance of moisture flows, heat gains from occupants, appliances and solar, ventilation rates and indoor air quality. As PAS 2035 is focused on energy efficiency, it doesn't include acoustic performance in this list, but that's also well worth considering, especially in change of use projects. Undertaking acoustic testing as early as possible in the project will allow acoustic upgrades to be designed and built in more easily than if applied retrospectively. While the other areas on this list are relatively predictable and can be assessed by calculation with a reasonable degree of accuracy, the same cannot be said for acoustics. Making sure the existing performance is properly tested before starting work allows the acoustic impact of all upgrade works to be factored in while changes can still be made easily. What methods do we use to assess these factors? The simplest step in the assessment is determining the U values of the existing envelope, and there's a range of software available to undertake this, but what's important is that the calculation method itself conforms to the methods given in the relevant standard documents, principally BS-EN ISO 6946-2017. It's also important that the calculation is conducted properly and any assumptions made are in line with accepted conventions. The standard methods and conventions for undertaking U-value calculations are given in BRE guidance document BR 443 2019, which gives guidance on the incorporation of thermal bridging, adjustments for fixings and air gaps and other factors that can influence the final calculated result. While there's a lot of scope for interpreting these factors differently in refurbishment jobs, it's important designers have an understanding of how these work when comparing calculation from different sources. Whilst most software includes material libraries, it's important the properties accurately reflect the existing building fabric, as it may not be appropriate to substitute the values given for modern materials. Building on the U-value calculation, the next step is hygrothermal assessments. Moisture control measures in buildings are detailed in BS 5250/2021, which references two standards for condensation risk. BS-EN ISO 13788/2012, Hygrothermal Performance of Building Components and Building Elements, Internal Surface Temperature to Avoid Critical Surface Humidity and Interstitial Condensation Calculation Methods, and BS-EN 15026/2007, Hygrothermal Performance of Building Components and Building Elements, Assessment of Moisture Transfer by Numerical Simulation. The 13788 standard uses the steady-state Glaser method to determine condensation risks, and our example here uses the ICOND software, which is linked to the BRE U-value calculator. This adds an additional layer of values to account for vapor transfer. As with U-values, it's important to ensure the values for permeability are appropriate to the building fabric under consideration. Glaser uses steady-state heat conduction, along with average monthly temperatures and vapor pressures to identify vapor diffusion and model how vapor passes through the building fabric. This gives a reasonable assessment with a comparatively simple process and simplifies data input requirements. However, there are limitations. The main problem is that this method only models moisture vapor flowing in a single direction, from warm spaces to cold, and completely ignores the effects of external moisture sources such as driving rain. The model also does not incorporate the effects of material porosity, moisture absorption, and water storage within the building fabric. As is stated in the 13788 standard itself, the method assumes built-in water has dried out and does not take account of a number of important physical phenomena. The other standard, BS-EN 15026/2007, addresses these issues with a new calculation method based around dynamic numerical simulation of moisture flows. This type of simulation provides a far more detailed and accurate representation of the way in which moisture both flows and accumulates in the fabric of buildings. This is the method specified for solid walls with internal insulation in BS 5250/2021, making its use more appropriate in traditional properties where this type of wall is more common. This more accurate simulation not only allows for greater variations in environmental conditions and material properties, but also offers a more flexible approach to simulation time periods. Designers can look at minute-by-minute predictions of the building performance, taking many years into the future if required. This additional detail in time can often reveal small problems that can grow to cause severe issues over the years, issues which would commonly be missed by a simple Glaser method calculation. The trade-off to using more advanced methods is more complex simulation software and outputs which are more complex to determine. Moving on from this, the energy efficiency of the entire building can be assessed. PAS 2035 recommends two methods for undertaking this: the SAP, or Standard Assessment Procedure Calculation, and the Passive House Planning Package, or PHPP. Both of these methods incorporate a wide range of data covering all aspects of the building fabric, orientation and systems, and will give a detailed and comprehensive overview of the pre- and post-upgrade performance. Because of this wide cross-section of data, the interactions between various measures can be accounted for. For example, the energy performance trade-offs between air leakage rates and insulation levels, and variations in the level of insulation in different areas. It's particularly useful as it allows most aspects of the thermal performance envelope to be traded off against one another. For example, by reducing air leakage to permit thinner insulation in areas with ornate cornicing or restricted space, larger rooms can also be insulated to a higher level to retain space in other areas. Although the reduced data or RDSAP calculation method is also available, this indeed was developed for refurbishment scenarios. PAS 2035 is cautious about its use as it makes a number of default assumptions that may not accurately reflect the building under consideration. That said, it may be appropriate to use for guidance purposes or to draw quick comparisons between a variety of different measures, provided these assumptions are understood and allowed for. Whichever holistic energy assessment is used, it should be remembered that neither SAP or PHPP account for the effect of upgrade works on moisture, so a separate condensation risk review should also be carried out. This holistic approach to design is well illustrated by figure D1 in PAS 2035, the Measures Interaction Matrix. This provides a simple, at-a-glance overview of likelihood of incompatibilities and problems arising between various upgrade works. For example, by looking at the matrix, systems which are not appropriate to be used together are highlighted red, such as the combination of decentralized mechanical extract ventilation and heat pumps. Orange interactions, such as that between electric storage heater replacement and heating controls, require additional consideration to ensure compatibility and may require additional complementary upgrade works. This is also true of yellow measures such as a combination of upgraded doors and windows and internal or external wall insulation, but to a lesser degree and more related to ensure good detailing and proper installation rather than significant changes to individual specifications. Green areas such as draft proofing and solar PV have little or no interactions or effect on each other, and therefore represent a very low-risk combination. The concept of risk in the specification of retrofit is further expanded upon in PAS 2035, with the project itself and individual measures being assigned degrees of risk. Depending on the nature of the project, 3 risk-based pathways are identified, A being the lowest risk and C being highest. Risk in this context can be considered analogous to complexity. For example, upgrade work to replace the windows of a single house out with conservation areas and of conventional construction will pose very little risk of complexity. By comparison, fitting internal insulation and mechanical ventilation with heat recovery to a listed solid-walled property will be graded much higher. Upgrade measures are also graded 1 to 3, with simple upgrades like draft proofing and hot water cylinder insulation at 1, and complex and disruptive measures like ventilation systems and heat pumps graded 3. The higher the identified risk pathway, the more pre-assessment measures are recommended, along with increasingly detailed project specifications and higher recommended qualifications for specifiers and installers. The recommendations in all the areas are extensive, so the PAS 2035 document, along with the accompanying PAS 2030, which covers installation processes, are well worth a read for anyone regularly undertaking retrofit projects, especially at scale. The processes and detailed recommendations are also a useful framework for anyone wishing to understand what's involved in upgrade works, even if the full framework is not being applied to the project. So let's now move on to look at 3 scenarios which commonly pose problems in the refurbishment of older properties, beginning with internal wall insulation. Solid walls, be they brickwork or stonework, are a common feature of older buildings, and often the stone or brick is an inherent feature of the external appearance. This can extend beyond an individual building to be a fundamental part of the character of an area. In such areas, even where not explicitly defined as a conservation area or listed building, the application of external insulation systems may not be desirable or practical. Internal wall insulation systems overcome a number of these problems, but typically introduce a few of their own. The main issue that can arise from internal systems are disruption to surfaces and decorative features, and condensation risks. The thickness of the internal insulation system can lead to extensive additional works to relocate switches, sockets, and other surfaces to accommodate the thicker walls, or cause problems if period decorative features such as cornicing must be retained. Ultra-thin insulation systems such as aerogel laminates, some with thicknesses as low as 13 mm, can go a long way to mitigating this. Because of the exponential nature of U values, even such a thin board can make a significant improvement thermally if no existing insulation is present. But getting closer to the insulation levels of a modern home will unfortunately necessitate a little disruption even with such high-performance systems. When using systems such as aerogels, all product details and installation practices should be reviewed in the context of the Control of Substances Hazardous to Health 2002 regulations, and manufacturers' installation guides and material safety data sheets should be consulted. Such products may require different installation practices when compared with traditional insulation materials, and specific data for the specified product should be reviewed. The fire performance of the system should be considered. Facing boards used in laminated systems such as plasterboard or magnesium oxide are typically classified as A1 or A2 under the EN 13501 Part 1 2018 standard, so they will comply with all approved Document B standards for linings, but in some situations additional requirements may apply. A good example of this is relevant buildings, as defined in Regulation 7, which are typically residential buildings over 18 metres high. In such cases, all materials which become part of an external wall or specified attachment must achieve Class A2 S1 D0 or Class A1, other than those exempted by Regulation 7, Part 3. Another issue, condensation risk, comes in two forms. Firstly, the risk of condensation forming at the interface between the insulation system and the original wall beneath. And secondly, risks arising in any area that cannot be insulated to the same degree as the main wall. In the first case, problems can arise because adding insulation to the wall makes the underlying building fabric colder than it would otherwise be, increasing the likelihood of the dew point occurring in this area. Avoiding this type of situation can generally be accomplished by hygrothermal analysis, using a dynamic simulation over an appropriate time period. By accounting for the moisture storage capacity of the materials and assessing the potential for inward as well as outward drying, this type of simulation can identify the optimum combination of vapor resistance and thermal insulation levels to minimize any negative moisture effects. The inherently permeable aerogel insulation systems offer a variety of thicknesses and can be specified with or without an integrated vapor control layer. This allows both the thermal and vapor resistance to be tailored to the specific project requirements, as assessed via WUFI dynamic simulation. In the case of window and door reveals, it's often difficult or impossible to introduce insulation to these areas without compromising the opening size and obstructing the glazing or opened areas. Whilst the effect of not insulating these areas on the overall heat loss is not huge, the bigger issue is condensation. If the majority of the wall area is insulated, but the reveals are not, the warmer surface of the insulated areas is offset by a decrease in the surface temperature where no insulation is present. So, internal wall insulation will actually make an uninsulated reveal colder than it was prior to the upgrade. This reduced surface temperature can give rise to surface condensation at the reveals, a problem only increased by the relatively lower temperature adjacent to the windows. Reducing this condensation can be achieved by adding even a minimal level of thermal insulation, bringing the surface temperature closer to the overall average for the wall surface. Again, a thin, high-performance aerogel laminate system can meet this requirement without duly encroaching on an open area. Such systems are available with A2 or better fire ratings, allowing them to be used in most circumstances, including facades and high-rise projects where additional fire performance requirements are necessary at over 18 metres, under approved document B in England and Wales, and over 11 metres in Scotland. This combination of fire and thermal performance can be particularly useful in larger scale projects such as facade retentions, by allowing fire and thermal bridging risks to be addressed with one system. If an A2 rated system is specified, it's important to ensure fire testing data and certification is both up to date and relevant to the application under consideration. This may vary considerably between systems, so as with any application where fire performance is a consideration, involving system manufacturers and installers early in the design process is recommended. As we discussed earlier, reducing the air leakage rate of a dwelling is often a more effective route to improving a building's energy performance, whilst adding minimal added thickness. How this can be achieved in a retrofit situation is, however, not always straightforward. Applying draft strips to doors and windows or completely replacing doors and windows will go a long way to reducing air leakage. In other situations, such as old floorboards or over-ventilated solums, or when fitting new internal insulation to a more air-permeable structure, it's more complex to achieve. The principal issue in such situations is how to limit air movement whilst ensuring no moisture is trapped. While lining the walls and floors with a polythene membrane may seem an obvious solution, this can also lead to problems as such a membrane may affect the flow of moisture across the element. As we saw in the dynamic assessment of moisture flow, inward drying and the ability of the building fabric to absorb and release moisture is an important component of maintaining hygrothermal equilibrium. So, the challenge is how to introduce an airtight layer without preventing this free flow. In these situations, a vapor-permeable self-adhesive air barrier membrane would provide a simple and moisture-neutral solution. Being self-adhesive, this type of membrane simply bonds onto the existing wall surface, providing an effective air barrier without impeding the movement of moisture vapour in either direction through the wall. The moisture-neutral property of this material means that insulation can then be added without causing a condensation risk, regardless of where in the wall or floor the insulation and the air barrier are placed. In refurbishment projects, this ability to locate the airtight layer more or less anywhere gives additional flexibility that may simplify the installation of services. Fire protection measures such as sprinklers or alarms, which will be required for most retrofit projects, can cause damage to airtight layers if penetrations are not adequately sealed. If the air barrier can be located away from such service runs, the potential for damage is minimised. To avoid puncturing the membrane, the finished floor must be installed a floating floor. And it's recommended that a protection fleece or fibre mat be considered to provide additional protection. This allows for the effective sealing not only of surfaces but also junctions, for example between a timber floor and a stone wall. Products that combine vapor-permeable aerogel insulation with a self-adhesive membrane provide a highly efficient thermal break as well as an air barrier. Because of the moisture vapor permeability of the aerogel insulation, it helps minimise moisture and damp problems, not only by permitting drying in any direction, but also by increasing surface temperature and helping reduce any cold spots associated with cold bridging. Such insulation panels can accept most common floor coverings. However, if a non-flexible floor finish such as laminate, engineered wood or ceramic tiles is specified, the advice of the floor covering supplier should be sought, as special measures may be required to accommodate possible deflection in the insulation panels. This degree of movement is small, and it's similar to that experienced when laying onto acoustic floor panels. However, additional measures such as flexible grout adhesive and/or additional plywood overlays may be recommended depending on the individual flooring product. The final scenario we will consider here is a re-roof, a daunting prospect for any building, but particularly difficult in traditional historic properties, which may have a variety of period details and features as well as less straightforward plan layouts. In roofs with complex geometry or rooms in the roof, it's not always simple to ensure ventilation can provide adequate airflow throughout the entire structure. A lot of existing roofs rely on air movement through leaky fabric, with lots of gaps and cracks to ensure moisture vapour can escape, so the lack of condensation problems can be more a case of luck than good design. Such systems cannot always be depended on to perform similarly post-upgrade, particularly if energy performance upgrades substantially alter the hygrothermal characteristics of the building fabric and envelope. Another particular problem is the condition of the existing ceiling, the performance of which may not be known. Some modern roofing membranes require the addition of a vapour control layer, or that the ceiling be well sealed in accordance with the BS 9250/2007 standard. And as with the provision of ventilation, this cannot be relied upon without a full replacement of the ceiling, which may or may not be possible or desirable. Taken together, these two facts make the choice of roof underlay crucial in ensuring the roof remains trouble-free after the upgrade works are completed. This is especially true if there is a large amount of wet trades involved in the refurbishment, as this additional moisture load must dry out over the initial heating periods. A well-designed and fail-safe roof construction can not only simplify the construction process, but will reduce the necessity for ongoing maintenance or remedial works, especially if subsequently changes of use or further alteration is anticipated. Although underlays are not exposed to fire from external sources, the finished roof covering should be classified appropriately to BS EN 13501 Part 5, 2016. The critical feature of any underlay used in such work must be the ability to accommodate as wide a range of existing situations as possible without requiring extensive additional enabling works. Particularly in historic or listed properties, getting the outer roof covering removed or any repair work done and the outer covering reinstated in the shortest time possible is paramount. Air and vapour permeability underlays do not require any additional ventilation below the underlay, nor do they require any special air or vapour control measure at ceiling level. Being air permeable, air is able to flow in and out across the entire surface of the roof, ensuring the most efficient transfer of moisture vapour possible, even during the initial dry-out phase after completion. This simplicity allows for trouble-free specification and installation on any size and shape of roof, with minimal changes to the existing building fabric required, meaning the roof can be reinstated as quickly as possible. Additionally, Construction Design and Management Regulations 2015 set out the duties placed on designers, and these must be referenced by both the architect specifying the system and the product manufacturer and installer who are designing the system. Responsibilities include the duty to eliminate, reduce, or control foreseeable health and safety risk through the design process, such as those that may arrive during construction work or in maintaining and using the building once built. Whatever your role in construction, CDM aims to improve health and safety in the industry by helping you 2. Sensibly plan the work so the risks involved are managed from start to finish. Have the right people for the right job at the right time. Cooperate and coordinate your work with others. Have the right information about the risks and how they are being managed. Communicate this information effectively to those who need to know. Consult and engage with workers about the risks and how they are being managed. In this context, the faster and simpler installation inherent in removing the ventilation requirements reduces the need for work at height, both during construction and due to remediation. And that concludes today's webinar, so we'll now move on to the Q&A session.
Good morning, everyone, and welcome to this morning's webinar. As probably most of you know, my name is Pamela Howitt, and I'm the Senior Technical Advisor here at the A Proctor Group. We're really delighted that so many people have joined us this morning on hopefully what is a sunny day and will be a bit of a drier, more pleasant weekend after the storms this week. Just thanks to everybody for attending again, and hope all are well. This is our 9th webinar of 2023. We've had more than 121,000 views to date of our webinars, and we hope to continue to grow that number. As you know, we're here to try and answer all of your questions, so please continue to ask them here. There's some great ones coming through on the YouTube feed. Feel free to DM us on Twitter or email us at webinar@proctorgroup.com, and you can use that email address if you've got any questions that come up after the presentation is finished this morning. If you would like to request a product sample pack, which will contain information and samples of all the products that we've discussed during today's webinar, or if you want to book a meeting with one of our team across the country to discuss a project, then you can do that again through our webinar page on our website, which is proctorgroup.com/webinar. You will get your personalised CPD certifications for today's webinar, and they're available from that same link. And you can register for our next webinar, which is on the 27th of October at 10 AM. And the subject will be airtightness for thin internal wall insulation systems. I'll give you a bit more information on that at the end, but just for just now, pop that down in your diary. So as Berry asked, you will get a link after this, and all of these presentations are still available and will be available to come back to online in our YouTube channel if you want to go back and revisit any point of them. And there's late registration is still available for this week's webinar, so that you'll get updated, etc., and get the replay link, etc. Okay, so without any further ado, I'm going to introduce you to our panel for this morning. All familiar faces to those that join us for our webinars on a regular basis. So I'd like to start by saying good morning to our Regional Sales Manager for Scotland and North England. Good morning, Linda. How are you?
Good morning, Pamela. Good morning, everyone. Fine, thank you.
Good, good.
At least it's sunny today in Scotland.
Absolutely. We're going to make the most of it, aren't we? We've got another of our regional sales managers who covers the southwest and Wales, a very beautiful part of the country, and that's Mark Blackie. Good morning, Mark. How are you?
Good morning, Pam. Good morning, everyone. Confirmed bright and sunny here in Cardiff.
Excellent. And good morning to our head of the SADS, James Brackenreid-Johnson, down on the south coast.
Good morning, Pam. Good morning, everybody.
And good morning to Jay Finch, our specification manager for London area. Is that right, Jay? Or do you just cover anywhere and wherever you're needed?
I'll go where needed, but predominantly London. Good morning, everyone.
Morning, everyone. Okay, so let's crack on with the questions. We've had quite a few come in already. Linda, can I come to you with one of the YouTube ones that came in from Amanda Jackson, please? She asks, I'm refurbishing an older property and looking at insulating a curved staircase and would like to use your Space Therm product. Can you advise which would be best? We do get this one quite a lot, so it's a great question, Amanda. Thank you.
Yes, it is, Amanda. It's one of those ones over the years, and we have a lot of queries on it. So when it comes to like a curved staircase, what we probably recommend mostly is the Space Therm blanket, because it's more pliable than like having it on a board. So we say you could actually fix it back with either battens or some sort of washer type insulation fixing is generally the recommended way we sort of go down, and then you could use something that's flexible, like a flexible plasterboard, or you could use ply or something like that. We've seen people use ply on these sort of situations. And then if there is another scenario that you could recommend, is the sort of just putting it back onto the wall, putting mesh on top, and then plaster on top of that. We have seen that, but that would be, I suppose, dependent on how much the staircase is getting used, because it could get damaged like that. So you'd have to consider those sort of factors within that. But that was recommendations.
Absolutely, and you're right, Linda. There are different types of mesh that you can get to give you a more robust finish as well. So it's making sure you speak to those people that like specialist plasters to make sure that they can give you the right advice as how to finish that off. But it's certainly doable and can give quite a good finish for curved or irregular surfaces, shall we call them?
Yes, I would go with irregular surfaces. That's a good one.
Thank you, Linda. Jay, can I come to you with Joseph Masterton's message on YouTube? He's an architect currently in the planning stages of refurbishing a period property. As it's a grade 2 listed, a conservation officer is assisting, and I think there was a few comments through the feed on that as well. Character and fabric are to be retained. How can I achieve improved U values without mechanical fixings into the substrate?
We actually get this question asked quite commonly now. I guess it's driven by the fact that older properties need to be refurbished to get them to a more modern standard. And in the YouTube feed, I haven't got my YouTube on the screen now, but was it Stephen and David were also putting questions about similar things?
Yeah.
I think if we look at it in a very practical sense, by the time a contractor or an architect has been appointed, if it's an owner-occupied home, they've probably already researched what they want, and then it's on that kind of person to then deliver on that message. It's quite hard, therefore, to get the two to marry up. You say a conservation officer is involved. In that sense, that adds even more complexity. So how do we therefore overlay a system which improves performance but doesn't disrupt anything? There's a comment about mechanical fixings, and in that sense, yeah, we've got a range of products that can be adhered to the surface, but to use Ian's expression, our technical director, it depends. So if you can send in some details, we'll certainly work out some solutions, but it's not to say there's a no. There are lots of solutions, but it's very hard for us to give an absolute answer to that until we know what we're dealing with. But yes, there are certain systems that can be adhered. But just whenever we look at changing the dynamics on an existing property, please always carry out some kind of analysis to make sure we're not inadvertently creating a subsequent issue with moisture control. So yes, it's great to put insulation in. We need to make sure that existing substrate is allowed to breathe and to get that moisture out and to have a different kind of change in that building's premise going forward.
Yeah,
bit of a waffle, but
absolutely, and it's really difficult to get something that's a complete non-mechanical fix, because you're always going to have things like boxes going through or kitchen units or shelving, which will always have to be taken back to the substrate unless you build a framing. So I
have to say, it is a little bit of a roulette when you speak to different conservation officers, because some will have a different understanding of some of the challenges that the main contractors or architects face. So it might take a bit more negotiation, but it's just something that needs to be optimized and worked through to make sure we preserve that building's character and fabric whilst also making it fit and appropriate and extending its lifespan for the future.
Yeah, it's a really good point, Jay. Thank you. Mark, can I come to you from Jessica Davison on YouTube feed? Can I retrofit my home to passive house standard?
Oh, it's a good question. So
I know how you like that.
The simple answer is yes, you can. So there's a dedicated standard in relation to passive house known as the Retrofit standard. So the Retrofit standard does give you a little bit more movement in achieving the required standard, but in essence, we'd be looking at elements such as heat recovery and ventilation, high performance windows, high specification insulation, be it internal or external, air sealing that envelope, and addressing any thermal bridges. But that Retrofit standard is the passive house standard, which is intended really for refurbishment projects, but does give you a little bit more room for movement to accommodate some of the challenges that you can find with a retrofit.
Brilliant, thank you, Mark. And James, just so you don't feel left out, if I can come to you with Greg Robertson's question. What should I look out for when planning a refurbishment?
Right. How long have you got? I mean, again, it's a conversation, obviously, with your projects that you're working on. Please get in touch with us so that we can go through sort of all the finite details in regards to it. But if you're looking at your residents at this moment in time, the quickest way of sort of identifying problem areas is obviously going outside of the property, looking at the external part of the build, the external facade, starting at the bottom, looking at your DPC, making sure that if somebody lived in the house previously, they haven't over-egged the DPC with hard landscaping, because obviously, as stated in the presentation, the external facade will have the ability of absorption, retention of water within that facade. So therefore, if you've got the bounce back off the hard surfaces onto that soft face of the brickwork, blockwork, sandstone, whatever it is, then the water level will increase within that substrate. And in turn, obviously, that potentially, if that becomes saturated and your cavity is therefore bridged by some slumping mineral wool or an insulation that's in there, then that potentially gets in the internal lining of your internal wall. So just making sure that you understand fully exactly what that substrate is that you're trying to enhance, whether it's to EnerFit standard or just bringing up to current regulation. And then moving up the walls, looking at the windows, looking at the doors, if they need to be replaced, if the glazing needs to be changed, if there's any blown panels, anything on that sort of line, making sure that around the perimeters of your windows and doors that you haven't got any unplanned air leakage or drafts, as we like to call it. Again, moving up the building again up to roof level, making sure you understand if you're doing a re-roof, if you're retiling, might as well do the membrane at the same time, understanding what membrane that is, understanding what's underneath the membrane, whether it's sarking board, whether it's rafters, making sure you understand what type of LR membrane you're using. So if you still need to have ventilation in your eaves, ridges and tiles, then so be it. If you want to enhance that, then obviously there's ability with third-party accreditation to get that sorted. The options are endless, but obviously if you've got a project that you're looking at, then please get in touch and we'll more than happily go through the ideas with you. Biggest thing of all, I could probably say, is the integration of architect, depending upon the size of the refurbishment that you're doing, the scale of the refurbishment that you're doing, is to get a initial thermal value carried out on your through wall, initial air tightness test, and initial EPC, because then you've got a basis of where to start from. And then obviously after works are complete, you can carry out those calculations again and see how much that building is improved by over the course of the remedial measures.
Absolutely, that's great. Thank you for that, James. And if I can stay with you, we got an email in before the webinar started from Enver James Cola. He's asking, can the Proctor Raptite product be used as part of a retrofit of the building's exterior in walls and over roof rafters? And saying, does it meet the air tightness requirements for Passive House or EnerFit certification? So things like, how can Raptite be used in walls and roofs to meet Passive House and EnerFit?
Yeah, I mean, the Raptite is registered with Passive House. It's Passive House certified. So yes, it can be utilized, but in regards to achieving Passive House standards, obviously, predominantly it comes down to installation of the material. So again, from our point of view, we get involved with toolbox talks on site. And then obviously we can do reports during the construction or during the refurbishment process in order to make sure that the material is installed properly. In regards to retrofit on the outside of a building, obviously depending upon the build type, so depending upon whether it's solid wall or cavity wall, we can have a look at that. If you want to Raptite internally, as per the webinar just now, you can obviously utilize the material internally. When it comes to utilizing Raptite on roofs, then predominantly it's on the warm roof scenario, not a cold roof scenario. So ultimately, you need to consider the fact that your ridge height will increase because you're putting insulation on top of your rafters. Then with a Raptite over the top, then depending upon the tiles, whether you need a single batten or a single batten with counter batten, and then your tile system on top of that. And then obviously junctioning that with your facade system, so making sure your eaves are prepped. Obviously, guttering systems, fascias, soffits, all that sort of business need to be taken into consideration. But to drastically enhance the external envelope in regards to air tightness, the product will definitely go a far way to achieving a Passive House or indeed an EnerFit standard.
Absolutely. Thank you, James. It's worth being aware that their aptite is fully self-adhesive, so you do need a substrate to put it on. So, you know, you can do it if you've got like a sark roof, etc. But do get in touch with more details of your project and technical, and they can go through that. That's great. Let's go through some of the YouTube questions, because there's lots of comments coming in, lots of information going on there. So I'll try and keep on top of it on the screens here. Dave, welcome to you, Dave. You're a regular follower. So you've got a couple of questions there relating to IWI for solid wall constructions, both in the scenario where the void between the lath and plaster and the wall is considered ventilated, and in situations where perhaps you remove that. So we've touched on this with a number of our webinars. I'm going to field this one, being the resident techie. So basically, I mean, our space therm can be used. Obviously, if you know you've got a fully ventilated void there, you add that into the calculation. So you basically negate the external wall insulation, and you're relying on that ventilation of that cavity to take away any moisture. So there are options there with space therm. Again, in terms of you've asked whether we've got a certified solution. Our systems aren't. There's so many variabilities of it. We don't have a certified solution like Weatherby, not where their system. I think it might be an external system. In a lot of cases, a lot depends on what extent of refurb you want to do in your building. So again, it's very much, it has to be considered case on case. And as G touched on, you know, look at the assessments and the moisture movement within that wall, depending on what solutions you go with. Linda, could I come to you for a question, please? This was an email came in from Dan Guterres. Apologies for my speech this morning. They're currently carrying out a loft conversion, and they've been asked to lay an acoustic floor. Can you advise which of our decks would be suitable, please?
As with any sort of loft conversion, you can use pretty much any sort of deck if you like. I suppose the one that's most commonly used is our solo deck. It's pretty much on the low performance side, and it is better with concrete floors. But you can use things like the dynamic deck, which is very good, and it's probably the most suitable one. And there's also the XL deck, which would give you a better performance. So it's kind of weighing up what your cost factors are, how much you want to spend with that, and what kind of performance you're actually looking for when it comes to these sort of loft conversions. Sometimes you just want to spend as little money as possible, but make a difference. So we have a few decks there. So do get in touch with us and we can go through your project with you.
Perfect, thank you. And I do apologise, the gardens have turned up to tidy up, so hopefully I'll not be too affected by noise at this side. Mark, can I come to you for one of the questions in the YouTube feed? It's from Paul Lewis, who says, I am a building surveyor working on an office conversion to resi. The external walls are solid stone with proposed 40mm insulated plasterboard internally. Does Proctor provide dew point calcs, etc.?
Yes, we do indeed. If you can supply the information of the actual build-up, then we can carry out that dynamic assessment and give you some recommendations for improvement. So yeah, we happily carry those out for you.
Yes, certainly. Just to put a wee codicil on that one, where our products are being used, so if our space therm is being used, that would be fine. Alternatively, if you wanted to look at definitely other types of insulation, we've got a brilliant free U-value calculator tool in our members area of our website. So sign in there, play about with calculations to your heart's content, and then you can send it to the team as well for review and checking, and we can coach you through using that software. So it's a really, really useful tool there. James, could I come to you with Berry Popovic? Sorry, my apologies for pronunciation of people's names. I have enough problems saying my own name on a daily basis. But he's asking, I have an external stair on a concrete slab with a habitable heated room below. Advice on insulation and waterproofing would be much appreciated. Thanks.
Is this on YouTube?
Yes, yeah. So it's an external stair in a concrete slab, and there's a habitable heated room below. So I'm guessing that it might be a sort of a room before, possibly an external staircase. Berry, if you can maybe give us a bit more information, we might be able to help. But I mean, waterproofing is really very much for external, isn't it?
Yes, I mean it's an external stair on a concrete slab and habitable heated room below. Yeah, so I mean, obviously heating from the warmer side, if that's a possibility, it would ease up obviously on the installation process. If you've got an external staircase based off of that slab, then obviously if you insulated on top of that, then the problem you're going to have is the fact that you'll encroach on the riser on the staircase, and therefore that will impede on regulation. So you need to make sure that obviously you don't do that. So therefore insulating underneath will be a viable option. So whether you utilize the space therm or another insulant, but obviously space therm will be the thinnest option available to you, which will maintain your floor to ceiling height internally in the heated space. In regards to waterproofing, then obviously there are a plethora of waterproofing companies out there. I would mention one, but I'm not going to. But if you get in touch, then obviously we can have a conversation with it. But what I'd state in that factor, because you're dealing with a staircase and a slab, I'd probably say make sure that you've got an anti-skid surface on there as well. So a granulated quartz or something on that sort of line to go into that material, in order to make sure that you retain that anti-skid. And indeed, you can take that up the staircase in order to make sure, depending on what the staircase is made of, you can take that up the staircase as well. But yes, insulating internally, again, will carry out, because if we put the waterproofing over the top of the slab, that will create basically a VCL effect. So therefore, we'll take that into consideration with the U-value calculation / hygrothermal assessment, in order to make sure that there's no interstitial or surface condensation created by that.
Absolutely. Yeah, so it is an external staircase. Jay, do you want to add to it, please?
Yeah, just looking through the feed, I think Barry's been in touch again to say if there's more questions later on. So I mean, it's certainly around what James has said. We can certainly help, but just get in touch via email or direct to our website and speak to the Supervising Tech team. Probably you, Pam. So,
yeah, I was going to say, it'll come to me and the rest of the team in technical, so we can help out. It's you do need to balance it carefully, because as James said and Jay said, if you've got that waterproofing layer, you have to be careful you're not trapping moisture in the building. But yeah, get in touch and we can talk through the intricacies of it. That's no problem at all. Okay, let's go through. So Jay, if I could come to this one for you, please. It's Kieran. Kieran McGowan on the YouTube. I'm not able to remove slates on a roof to put in roof shield. What recommendations do you have if I can gain access to the underside of the roof, i.e. from the internal side? That's a good one. We get asked this quite a lot. It's
a really tricky question though, because let's not forget that the membrane's predominant kind of task is for weather protection. If that's underneath trusses, whatever the system is, if it's set back from that outer surface, it's going to negate its ability somewhat. So in that sense, you know, to put a roof shield type material on, that would often necessitate stripping the outer surface. It depends on what the objective is, I guess, doesn't it? Is it the case of sealing in energy? Is there some other plan behind that? What's the reason for putting that further down? So once we've got an understanding of what the premise is on that project, then of course we can come up with a solution. But I'm not, in my ignorance, to convince
I mean,
within that arena.
Assuming your membrane, or assuming your roof is still watertight, and you're not needing to replace it, then a lot will depend on what's there. So either you have no membrane, in which case you might want to use an insulation that is going to be less affected by any wind-driven, storm-driven snow and rain through that. But in theory, you can sort of drop the insulation down within the rafters and then insulate underneath. So perhaps a combination of more traditional rigid types of insulation or mineral wool bats suitable for that scenario, combined with space therm.
Online, if you can just let us know if there's an existing membrane there. If, for example, it's an HR membrane, that's going to have a massive impact on what you put underneath it.
Yeah.
So just need a bit more detail about what's there already and what the reason is for putting some secondary measure, and then we can come up with an optimized.
Absolutely. There's definitely ways to look at improving the performance from whatever aspect you're looking at. So to give us a bit more context, we can help you with that one.
Yeah. And
Mark, if I can come to you for Kieran's second question here. If I use space there multi on a concrete floor and plan to use sisal wool or other natural insulation for stone walls, what steps should be taken for the edge areas between floors and walls?
Oh, it's a good question, really. I guess what you need to be looking at really is making sure that you've got an air tightness membrane between the wall and floors. You could use wrap-tight floor zone in that respect, and just making sure you've got that air tightness covered really between that, I guess.
Yeah, and just making sure you can either take your wall insulation down first and then butt your insulation across, which is going to limit the cold bridging, and then utilising things like our flanking strip edge protection to just stop off that cold bridge as well. So that's part of the space there multi for floors options. So it's really just looking at the continuity and the junctioning detail there to reduce it. Yeah, absolutely. Thank you, Mark. Okay, Mark, if I can stay with you, we've had a couple of questions in, one from JDB768 on YouTube, which ties in actually to one that came in by a direct message to us from Madison Giles. So Madison asks, what is the difference between PAS 2030 and PAS 2035? And JDB768 has asked, where can I get a copy of that?
Right, so that is a question that often does come up. It was mentioned in the presentation there. So the PAS 2035 is kind of a framework for preparing plans for retrofit projects. So any retrofit designs that emerge from those specifications must then be installed in accordance with the requirements outlined in PAS 2030. Now, PAS 2030 is the certification for installation compliance. So the PAS 2035 isn't a certification, it's more of a tool for setting the specification, but both documents should be taken as a whole because they're closely related to each other. In terms of getting access to those documents, they're freely available on the BSI website, which we can give a link in the comments for that.
That's great, thanks, Mark. Jay, can I come back to you? Another email that's come in from Kenneth Campbell saying, my property has shiplap timber on the outside, so obviously a timber-clad building. If I remove this, can I use space there and behind it in the cavity?
Officially, yes. It really depends on what the weather protection is from that shiplap. I didn't say how old the property is. So if it's an older property which features shiplap timber, we have to ascertain if it's listed or not, all that kind of conservation issue. But then we've got to figure out how weatherproof that outer rain screen kind of covering is. If we can't give an assurance of an existing state, we're taking the shiplap timbers back off with the assumption we're putting the existing ones back on again. It's a bit of an open question on that one. Then we need to preserve that material. So ultimately speaking, space then would normally be an internal system, but there are times it can be used externally if there is some weather protection. So it might be a case of introducing a membrane over the top. It might be relying on purely on the shiplap itself. But again, send details in, we'll get something figured out for you. Just as a little point, I see that Kieran's got back in touch again. Thanks for kind of qualifying those other bits. I think in that instance, it's probably better if you can just send some details through rather than digging too deep into it today, but we can find a solution. And the same
so
for the shiplap.
Absolutely. I mean, certainly
depends on
yeah. In that one, you know, sort of a combination of some insulation between and some insulation below, well fitted staggered joints will help towards improving that thermal and air leakage through that room.
One handy thing we haven't really covered on too much today in terms of space therm, as an aerogel material, it naturally repels liquid water. So in that kind of scenario, it works better than other more porous kind of insulation materials. So there is a significant difference to that, to other products that are available. So that has to be factored in, certainly that kind of context as well.
Yeah, absolutely. James, if I can come to you, a DM came in from Anish Stevens. How can I improve the air tightness of my home?
Right. Improving the air tightness of your home. Initially, obviously, looking at windows, doors, obviously negating those unplanned air movements, obviously around the windows and doors. Junctions generically throughout the construction will be your main failure point, or penetrations that go through that external wall system. But again, taking a step back from that, understanding what's going on inside the property. So, you know, and therefore you need to, if you're going to make it a lot more airtight, you may need to involve some sort of mechanical ventilation or passive ventilation system within that house in order to make sure that you've got the air changes going on. Obviously, if you've got a chimney in the house, then obviously that's going to be a very large air leakage point. So it'll be the fact that that needs to be boarded up, boxed up, sealed up properly. But again, you've got to take into consideration the usage of that property, the usage of that room where you're boarding up those areas or sealing up those areas. So there are many ways in which you can do it, some expensive, some not so much expensive. But again, if it's an area that we can look at with you, then we will do, no worries at all. Again, as mentioned in the webinar, as mentioned in the conversation we've been having here, utilising the wrap type from an internal perspective is a way of enhancing the airtightness of your property.
Yeah. And it's worth noting that, you know, a lot of these solutions we're talking about, although they seem to be skewed quite heavily towards domestic, these principles are suitable across the board, from you know, non-residential into residential, residential into offices, commercial. All of these, the principles are the same. Obviously, some scenarios such as homes do generate more moisture and therefore are a little bit more sensitive to changes to the actual physics of the building.
Yeah, I mean, again, there's regulations coming in to stipulate that obviously commercial units, commercial buildings need to achieve certain performance energy efficiency standards by 2025, and the repercussions for the landlords if those demands aren't met is going to be expensive. Yeah. So yes, it does go for commercial buildings as well.
Absolutely. And James, if you don't mind me staying with you for a question that came in from YouTube, from Matthew Nichol, only because I know we have had many discussions on this particular topic over the years. Right. Matthew asks, is the Spacetherm blanket product suitable for insulating an existing flat roof in conjunction with tapered insulation to create falls to drains without adding too much depth?
As a hybrid system, then yes, it is not. I mean, you know, the Spacetherm product is a hydrophobic product, so it naturally repels water from it. Again, it's looking at the fire classifications. Obviously, the fire classifications for roofs are a lot less than what you'll be looking at for a facade system. But integrating Spacetherm into a flat roofing is a possible venture. But again, it's something we need to look at, including your upstands, in order to make sure that the correct material is specified in the correct place and in the correct order.
Yeah, absolutely. Linda, I'm going to come to you because we've not heard from you for a while, and we know that you love your acoustics and you're really good at it. So there's another acoustics question coming in from Darcy Bruce via DM. And they've asked, we are going to be putting down an acoustic deck on our concrete floor. Do acoustic decks need to be laid at a certain time and certain temperature? Brilliant question that doesn't get considered enough.
I'm actually thinking that's just never asked. Yeah, really good question. We don't actually say a specific temperature for the installation. I suppose it's one of those things that if you look at sort of wood-based sort of particle boards, you're going to bring them in and you're going to acclimatise them to your room before you actually lay them down anyway. So you probably, most joiners would do that when they're doing an install. So it's just like putting down a normal sort of chipboard, if you like. But I think what you've really got to think about when it comes to acoustics when you actually lay boards. So really you want to lay them as late in the project as possible, because if you've got any sort of concrete there, you want to sort of get that to dry out as much as possible before you actually lay your boards down. So it's just trying to sort of schedule the project as you go along. But if you're looking at acoustic performance, I would say give us a shout, depending on, you might need something better than what you're thinking of putting down, or you might need something less. So give us a shout to actually speak about acoustics. You can ask technical team at any point. I'm not the expert.
Yeah, I mean, it's one of the areas where we're actually very lucky. We've got a vast database of actual on-site testing with our acoustic products from over the years. So it's really good to be able to look at sort of non-traditional or more unusual constructions and try and correlate it. So those databases allows us to get a good idea of how your floor might perform in the end and how it might perform with different products, and therefore what's the best to go with. So yeah, it's easy to work with in that. I'm getting close to the last sort of 4 to 5 questions. There's a few more coming in, so if anybody else wants to add any more questions and send them across to us, now's the time to do it, or you can follow up by emailing us. Jay, can I come to you with Polished Silver Stacker on YouTube's asked, is it possible to install aerogel mats underneath the slab over a basement to keep minimal height of basement as per regs? So the basement is not heated and there's a habitable room above, so it's almost like an exposed soffit, I suppose, to unheated space.
The answer would be technically yes. Once again, we need to draw into details to have a look at it in a bit more complexity. The space therm range is vast. You can use it for flooring. You can use it, as a blanket to put into separate cavities. You can use it as a wallboard. It just depends on the application and what the substrate's like. We keep saying again about what's the relative humidity, how's that dynamic state at that point. So we can't disrupt that. We've got to work in conjunction with that existing building. So once again, and I'm sorry to repeat the same question, if you have a specific, get in touch and we'll come back with an appropriate answer. It's very hard verbally to give a specific answer without knowing all the challenges around that.
I mean, it's certainly feasible, and we do quite a lot of ones like that in the tech team. So yeah, give us a shout and we can look at that for you. That's no problem. Thank you. Mark, can I come to you? This is one that's come in by email, and it's a great one because we've not really touched on it in this webinar so far. Can ground gas protection be installed retrospectively? And I think this is quite important because there's a lot more emphasis on radon, especially with the update in maps and things like that.
Absolutely, great question. So in terms of ground gas protection, it can be fitted to existing buildings, and it's a question that often comes up when an extension is being built, and then the planning permission kind of highlights the requirement for ground gas protection. So that sort of triggers most homeowners to then want to add gas protection to the existing house. Now, there is a guidance document produced by Syria. It's the Retrofitting Ground Gas Protection, and we can put a link in the comments box. It's not as simple as installing protective measures during a new build construction stage, but you can dramatically reduce that risk. So yes, so in essence, you can, yes.
Yeah, absolutely. It isn't as straightforward as just raggling it into the wall or sticking a bit of tape around the perimeter. Depends very much, but that's a great document to put you in the right direction of that. And obviously there's a number of people that excel in that in terms of installation across the country. Okay, so James, can I come to you with this one from Ellen Kuvaris from YouTube? How safe is aerogel in terms of respiration, thinking especially future replacement, etc.?
Again, I mean, from a cost assessment, that side of things, we provide documentation stating that when the material is being cut, whether it's bonded to an MGO board or not, a mask is worn, an appropriate mask is worn, because obviously there is dust emitted from the product. When installing, what we utilize is where the junctions in the boards are. We tape those junctions in the boards in order to make sure that when the board is compressed, that dust doesn't come up from material through the junctions and into the habitable space. So from a respiration point of view, as long as the correct, from a cutting point of view, as long as the correct PPE is worn, then that's absolutely fine. And then obviously from an installation point of view, as long as you follow the guidelines that we put together, then that will be absolutely fine indeed.
Jay, please.
Just add to that. She's mentioned about future replacement. Just to clarify, that if you look at the difference between most fibrous materials and an aerogel material, the lifespan is significantly longer. So I would hope they're not going to plan for replacement in the short frame. It might be a case of extending or changing that building's use in the future, which is relevant. But replacement's less of a requirement than it might be with similar kind of fibrous materials.
Absolutely, and you just took the words out of my mouth there.
I think again,
Space Therm's got, you know, a lifespan. It's been you know, artificially aged up to 50 years. So I would say for most of us, if we install Space Therm now, replacing it is not going to be something that's going to bother us within our lifetimes or within our, you know, time in that particular property. So it's not like other types of insulation that might have a finite life of maybe only 10 or 15 years. It's a long-term investment in your building's energy efficiency. But like all materials, building materials, the appropriate PPE is what's to be used when you're handling it.
And again, there's no off-gassing from the product, so there's no depletion in the lambda of the product over the course of its lifetime.
Absolutely. And if I can stay with, if I can go back to Jay, because I know this is one that you've dealt with in the past. Kia Turner's email to say my house is a mold issue, so it sort of feeds on from this discussion.
So does
and
mine.
I've tried various chemicals to remove it. How can I fix the problem? It's a real issue in a lot of housing stock.
I can say with some authority that using a chemical to fix mold, it doesn't fix the problem, it just takes the symptom away. So we have to look at why the mold is occurring. And the more we drive to having, you know, keeping energy in homes, having air tightness models, convection-based models, typically in homes that used to be kind of drafty and got rid of that moisture, as you covered earlier on, we've created a problem. Airborne moisture is a relatively new concept. So what we've got to do is not cure the wiping the mold off the wall. We've got to get to the root cause of everything. And that really, again, ties into understanding what the dynamics of the building are. If you've got an older building and we've made it more contemporary, we've sealed things up with different materials, it doesn't always fit. And the first cause we see from that is mold growth, and then the knock-on effects in terms of the degradation of material, the dampness and everything else that kind of insidiously creeps in. So in your instance, I would say, why is it occurring? What's changed in that building? Address that first, and then hopefully that in itself will fix the problem. Unfortunately, chemicals in that instance don't really do that quite so well.
Yeah, absolutely. James, can I come to you for one of our last couple of questions?
Yeah.
Umair Wood has DM'd us and said, how can I insulate an existing slab without drastically affecting the doors and skirting boards?
Right, by utilising the Space Therm Multi, which we put on a flooring scenario or indeed a loft board scenario. So you've got a 6mm MGO board, so you've got that resistance. Obviously, MGO is a very, very hard board, so similar to a calcium silica or a cement particle board, if you're aware of those products. So therefore, the point loading, obviously, from pedestals, from kitchen units, so on and so forth, it will be able to have the resilience there. Again, I mean, obviously we can go to, well, not obviously, but we can go down to sort of a 10mm product to negate any cold bridge through that floor slab and therefore enhance the flooring system. Obviously, if you've got the ability to go thicker, then so be it. For every 10mm of the product, you do have a 1mm compression. So that needs to be taken into consideration. What you're putting onto the product obviously needs to be taken into consideration, and where those point loadings will be. But yeah, I mean, for the use of a better word, it's the best and only product that you can utilize to insulate on top of a slab where you don't want to impede the door, you know, shaving off the bottom of the door or impeding on your skirting boards.
Perfect, thank you. Last couple of questions. So if there's anything else, please send them now and we'll try and get them. On YouTube, we've got P. Marisma Del Sal saying, I've a south-facing property with a brick cavity wall which overheats in the summer during recent heat waves. Can Space Therm be applied to this elevation if a rain screen is then installed over this? In theory, yes. I mean, we've touched on the use of it externally as well. With it being a cavity wall, cavity insulation along with some other insulation might be a solution if you get the right balance of permeability, etc., and placement. You could update external insulation as a possibility. You could look at internal. A lot will depend on how that building is overheating. So it might be things like your windows, are actually causing a lot of heat gain in. So things like some shading, etc., might actually be a better option. But overheating is becoming a huge issue. I don't know whether any of the other guys, James or Jay, you must get this down in London, and with facades, overheating being a real issue, starting to affect a lot of buildings.
Yes, I mean, it's something that everybody's looking at and looking into, and obviously with our hygrothermal assessment, obviously it's showing the fact that things are getting warmer and drier. So therefore, taking into consideration solar gains is a massive thing, whether it be new build, whether it be retrofit. So involving louvers, involving blinds, so to speak, even to the simplest of standards in regards to disallowing the volume of solar gains within the properties, and just making sure that you've got the correct percentage of opening to floor space in each and individual room of the property.
Yeah, it can certainly help, but there's lots of things that you need to look at for overheating. But that's great, thank you. Quick question just come in from Steve Ruther on YouTube. If maintenance of the building is not kept up and space therm gets wet, and the opportunity of it drying out by ventilation is there, has it the ability to dry and perform the same standards again? That's an easy one. Space therm is hydrophobic. It's completely unaffected by moisture. Unlike mineral wools, it won't actually hold on to the moisture. You can basically put a piece of space therm in a bucket of water, lift it out after a week, it drips off, and there's no moisture actually inherently held in it. So from that point of view, it's brilliant for buildings that are maybe wet and dry out. You get the two-way drying off it, as Jay touched on earlier with the hydrophobic, hygrothermal movement of the moisture through the walls. So it's not something that, it's what makes it really good for refurbishment and neglected buildings. So there's no problem there. I think that's all the questions. There was some comments from Stephen Scasebrook earlier on. Great to see you. And it's really just to sort of summarise what we've talked about in all this, and that the guys have touched on in their answers to all the questions that we've had in. Where you've got historic buildings, where you've got existing buildings, there is no hard and fast rules. You do have to look at each one individually, and you do have to be very careful. There's no point in doing a massive thermal upgrade internally and still have leaking downpipes or water coming in your windows and roofs. It's really very much a case of looking at what can benefit the building and what can't, and sometimes having to make some very difficult trade-offs. But it is definitely worth investing in the fabric of the building, not just in what the internal building looks like. So put a few more £1,000 to your insulation and cut back on your marble-topped kitchen work units, and you'll have a building that will last you for years. Okay, I think, yeah, I mean, Steve's saying there, sorry, just following up, a lot of PIR when it gets wet, etc., just being ripped out after a few years. I mean, these are finite resources, so it's definitely a problem if people don't maintain their buildings, and it's difficult. Okay, so I'm going to round up now, just sort of say thank you very much to the panel here for answering all the questions and keeping on track with me, waffling away as usual. Thanks guys for your support. Huge thanks again to everybody backstage and behind the scenes that do all the bits that keep all this side of things flowing. We can't really run these webinars without them, so thanks guys. Just to go a bit more detail as to what our next webinar is, which is on the 27th of October at the usual time of 10 AM. We're looking at airtightness for thin internal wall insulation systems. So this is going more in depth on just that internal wall insulation. So RAPtight, as you know, is the only self-adhering vapor permeable air barrier certified by the BBA, and combines the critical properties of vapor permeability and airtightness in one self-adhering membrane. This approach saves on both the labour and material costs associated with achieving the energy efficiency demands in buildings. So we're going to look at specifically wrap type being used with internal wall insulation. So not externally as would be more traditional, but how can it relate to internal systems, how that fits in with airtightness and retrofit and the benefits of that. Looking at integrating MVHR into retrofit systems, the moisture management for internal wall systems, and also we'll be going into some information on on-site project delivery and installation. And we'll have our normal Q&A afterwards. And hopefully, all going well, Kira will be back with us hosting, although I've enjoyed my couple of stints, but we have to pass our congratulations on to Kira and her husband, who have welcomed a beautiful baby girl into their family. So they're having some family time just now before she comes back to join us again for the next webinar. Right, I think that's about it. It's nearly time for us here at head office to head to our Macmillan coffee morning. The boardroom table is groaning with cakes and things, so I'm not going to miss out. Have a great weekend, everybody, and we will see you at next month's webinar. Thanks and bye.